Hello everyone and welcome to my channel. In today's video I'm going to talk to you about SketchUp basics. I'm going to tell you the conditions of a valid sketch. Now this is before I even tell you the tools that I use to make a sketch, because these conditions are something that you need to keep in mind while making a sketch. So it's of utmost importance that you remember these conditions and abide by them while making a sketch. I will show you some customizations that you can perform in SketchUp Workbench so that it fits your need. So we'll look at those customizations as well. In the end, I will talk to you about three toolbars, which are Sketch Tools toolbar, Standard toolbar and View toolbar. Now these topics have a great overlap, so I may jump from one topic to another. I may skip something in the middle, but I'll cover it all. So let's begin. I'll start with the Sketch Tools toolbar. Let us have a look at what are the different tools that are present in this particular toolbar. I'll show them to you in CATIA itself. Now if you have opened CATIA, you may remember that this is the file that opens by default and we need to close it. So I'll simply click here and close it. I'll go to Start, Mechanical and Sketcher. You can either go to Sketcher or you can go to Part Design, it's your choice. I'll go to Sketcher. If you want to give a name, you can give a name from here, say OK. Now since I went into Sketcher, you can see that this tool, which is you need to select for making a sketch, comes pre-selected. Okay, so all you have to do is select a plane from here. As you can also see from the prompt zone that it is asking you to select a plane. Okay, so you can select any plane from here, or you can select a plane from the specification tree. After you select the plane, you will see that your view orients perpendicular to that plane, and all the tools that are available in the SketchUp Workbench are shown to you and you are taken to the SketchUp Workbench. Okay, now you can start sketching if you want, but before we sketch we need to look at the first toolbar that we need to discuss today, that is the Sketch Tools toolbar. Let me just bring it here. Now the first tool that you see here is the grid. If I click on this, I'll be able to see a grid on my sketch plane. Okay, so you can use this tool to turn the grid on or off. Okay, now second tool that you see here is snap to the point. Okay, now the grid that you see here, you can use this grid to draw a sketch as per your preference, and this snap to point will actually help you to create your sketch. If you want, you can use this, and when I turn this on and try to create a sketch, you can see that my cursor is snapping to the points where my grid is, or my grid points are. Okay, so when you turn snap to point on, your cursor will actually snap to the points that are there on the grid. Now we can change the grid spacing if we want. We'll see how to change the grid spacing just in a moment, but for the time being you can understand that this is used to turn the snap to point on, while this is used to turn the grid on or off. Now both these work independently. If you want to just turn the snap on, you can use it from here. If you want to turn the grid on, you can use it from here. Both can work independently from each other. Okay, and the snap will actually work only when you start drawing. Okay, if I turn the snap on and now you can see my cursor is not snapping. Okay, if I start to draw, then you can see that my cursor is snapping to the points where my grid points are located. Okay, now in certain situations this grid may come in handy and you can turn it on. We'll see how to change the grid spacing later on. Let's move on to the next tool that's available, which is Standard Construction Element. Now if you see, when I previously created a rectangle like this, you can see that the line that's made is a solid line. Okay, now if I want to make a construction line, what I can do is I can select this tool and then try to create a rectangle. Can you see that the rectangle that's now been made is a construction line. Okay, it's made out of construction line. So that is how you can create a construction element. This tool can be used to create standard or construction element. When this is not selected, it will make a standard line, while when it is selected, it will make a construction line. Okay, now you have to keep in mind that construction line is only for our help. This will not be considered as a sketch when we are making a part. Okay, we'll see what's the use of this. For the time being, just understand how we can create a construction line or how we can create a standard line. Okay, we can do it using this tool. Okay, let me just turn this off since I need to create a solid line. Okay, also when I'm creating a rectangle, can you see that automatically it has this edge displayed here and this edge displayed here on these two lines, while V is displayed on these two lines. Okay, now what does it signify is that this line has a certain constraint, which is horizontal constraint. That means that this line will remain horizontal no matter what you try to do. It will remain horizontal. Likewise, these two lines that you see here, these will remain vertical no matter what you try to do, because this constraint has been applied. Okay, this is V stands for vertical constraint and H stands for horizontal constraints. These constraints that you see, that is horizontal, vertical, and some other, say suppose tangency, concentricity, etc. These constraints fall into the category of geometric constraint. Since they govern the sketch geometrically, these constraints are known as geometric constraints. Now, I did not apply these constraints. You can see that when I created a rectangle, I did not apply these constraints. These are automatically created. Okay, now it's happening because I have selected here as geometrical constraint. Now this tool and this tool, they come selected by default. Okay, these two are basically, first is the implicit geometrical constraint, second is the implicit dimensional constraint. If I turn the implicit geometrical constraints as off, and next time suppose if I create a rectangle, you'll see that the horizontal and the vertical constraints are not applied automatically. Okay, this is to turn the geometrical constraint as off. That means when this thing is off, you won't see geometrical constraints getting created on their own. You have to create them if you want. Okay, but we'll keep this as selected since we want to create the geometrical constraints on its own. Okay, this makes a sketch process easier, so we keep these as selected. The same goes for dimensional constraints. Suppose if I try to create a circle, suppose from here, when I selected the circle tool, you can see that the sketch tools toolbar expanded to give me more options. Now this would happen every time you try to create something or apply some operation in Sketcher. You will see that the sketch tool will expand to give you the options that are relevant to that particular tool. Okay, so what you can do is you can actually, instead of clicking on the screen, you can also specify the center location from this dialog box. You can specify the horizontal distance, you can specify the vertical distance of the center point, and also specify the radius value if you want from here itself. Okay, so that is how it helps us to use the sketch tools. But what I want to demonstrate to you is, suppose if I give it some value, I want it at a horizontal distance of 10 centimeters, vertical distance of 10 centimeters, and I want it to have a radius value of 20. Okay, now if I fit all in, you can see that a circle has been created which is at a distance of 10 centimeter from vertical, 10 centimeter from horizontal, and it has a radius of 20 centimeters. Okay, but did you see that I did not apply any of these constraints, but these constraints were created automatically. Okay, now it happened because this particular tool, that is dimensional constraint or implicit dimensional constraint, was selected. So when this tool is selected, it will automatically create dimensional constraints as well. Let me just demonstrate this to you while turning this off. Suppose if I turn this off, if I now try to create a circle, let me just give it some value of 5, and I'll give it some radius value of, say, suppose, let me give it up, say 6, okay, 6 cm. Now can you see that the circle, although it has been created where I desired, but the dimensions have not been applied, okay? Can you see that I can move this circle, okay? It is, although of the value that I specified, okay, it is having a 6 radius, but the circle that was created, it does not have those dimensions because this implicit dimensional constraint was off. So I just want to demonstrate what these two tools do. By default, these two come as selected. We'll keep them as selected because it makes our sketch process easier, okay? Now let us have a look at the standard toolbar and all the tools that are available in this particular toolbar. Let me just bring this toolbar out from the bottom left portion, and you can see. Now the tools that are available in this particular toolbar are the tools that you are already using in Windows. The first tool that you see here is New. You can also access this tool using Control N, and this will open a dialog box that will help you select the new file that you want to create. You can select the type of file that you want to create and say OK. We have already used this tool to create a new file of part type, right? Cat part file. We have already seen how to use this using Control N, okay? Since I don't want to create it, I'll hit cancel. But if you want to create a new file, you can click on this, or you can press Control N from the keyboard. You can also open a file from the standard toolbar using the open tool, or you can press Control O from the keyboard to open a file, and this will also open a dialog box and you can select a file that you wish to open, okay? Save as it works in other Windows program. You can press Control S or simply save, okay? From here you can print using quick print. Now this print command is different from Control P command that you do. Control P will open a dialog box that will help you select the print options, all the print options that are available, okay? It will help you select all the print options that are available. But if you can also set a page from here, you can preview options. There are a whole lot of options available here. Now the quick print command is different in a sense that when you press this quick print command, it will automatically select all the options that you previously defined in the print dialog box. That is the dialog box that comes up using Control P. All the options that are selected in that particular dialog box, it will execute a print using all those options, okay? So you don't need to make changes every time. If you need to make changes, you can press Control P key combination and change the settings if you want. But you simply need to give a print using the previous settings that you used. You can use this quick print command, okay? Now the cut option is available, copy is available, paste is available. All these options are just as you would use in other Windows program. So right now it's not highlighted because there's nothing available on the screen. Suppose if I create a circle and if I want to cut the circle and paste it, I can select it, say cut, and if I want to paste it, I can simply say paste. It will paste it in its default location, okay? Now this may not seem very useful, and it isn't, but if you want to simply create copies, multiple copies, you can go on pasting and it will create multiple copies and all copies will be the same. As you can see, I've created multiple copies using paste command and all those copies are the same. Now cut, copy and paste are also used in other cases. When we proceed further, we'll see how we can use these three tools very efficiently to create sketches faster. For the time being, you can see that this is how it works. I can select a circle, I can copy also. If I copy this and paste it, it will create a copy of that circle, okay? I can create as many copies, I can cut, I can paste, okay? undo and redo as it works in other Windows program. It works here as well. Okay, I can undo. Okay, I can redo if I want. Okay, but here is the difference, that you also have an option of undo with history and redo with history. So you can actually select from the history which part you want to redo or undo. Okay, you can do it from here. Now this option, what's this is, it will give you more help about a tool. Suppose if I click on this and go to a tool and select that tool, it will give me more information about that tool. If I click on more info, it will ask me the document installation path. If you have a CATIA help file, you can give that path and say okay, it will give you more information about that particular tool that you selected. Okay, since I don't have a CATIA help file, I cannot do this, but this is how this tool works. That is, what's this? You can also access it using Shift F1. Okay, so that is how standard toolbar works. So let's move on to the next toolbar, which is view toolbar. Okay, the view toolbar that you see here, it has set of options. The first option is fly mode. I won't discuss it today. I will discuss it perhaps when we do part design. It makes sense that we do it when we do part design. Let us first see how fit all in works. Okay, suppose if you have created a sketch, okay, and for some reason you are zoomed in too much, I've zoomed in too much, okay, and I can't see all of my sketch. If you want to bring each and every element of your sketch within your view, what you will do is you will press this fit all in. Okay, if I press this, all the elements of my sketch will actually come within my view. Okay, that is how you use the fit all in button. Okay, you can also use the pan, rotate, zoom in and out as you do in using transformation pad, or as you use it with the mouse. You can zoom out, zoom in, rotate if you want using your cursor, left mouse button. You can pan if you want. Okay, if you use these tools, you don't need to use all the buttons of your mouse to do as you were doing, say, when we were learning about how to use mouse. You can simply use these tools and also manipulate your sketch. Okay, now as you can see that my sketch has been oriented in a way that it makes it difficult to see what elements there are in my sketch. If you want to go to the default view, that is the view in which you were actually perpendicular to that sketch plane in which you were sketching, what you can do is you can click here, that is normal view. Okay, this will orient you perpendicular to the sketch plane in which you were sketching. If I select it again, it will show me the sketch from other side. Okay, if I click it again, it will show me the sketch from other side. That's how this works, which is normal view. Okay, if I want to have multiple windows within my screen, if I want to have a look at my sketch from many different angles, I can use this create multi-view tool, and it will give me 4 windows which I can manipulate independently and have a look at my sketch from all possible angles. Now this is not very useful in case of Sketcher, but if you are suppose creating a part design, you can of course use this to have a look at your part from many different angles. Okay, now you can manipulate each of these windows separately. If you click on a particular window, that window will become highlighted. Okay, if I click normal view, it will create a view which is normal to the sketch plane in that particular window. Likewise, suppose if I click here, okay, this window will become active and I can manipulate this window. Okay, if I want to manipulate this window, I'll click here and I can manipulate this window if I want. Okay, so that is how this works if I create multi-view. Okay, I don't want a multi-view, I will simply exit this. Now remember, the view that is selected, and that view will become the main view when you exit the multi-view. Suppose if I click in this particular window. Okay, now this window is the view. The view in this particular window will become the main view when I switch this off. Okay, so that is how this works. This is multi-view, create multi-view. Okay, not very useful in this particular situation, but if you have a part on your window, that is how it will work. Okay, these are some preset views that you can use to create or basically view your part or sketch. This is isometric view. Okay, and other possible views that you can use, that is front view, back view, bottom view, top view, left view. Okay, all those views you can use from here. Not very useful in this case. We'll see how to use it in part design. Next is viewing style. Okay, you can change the viewing style of your part using this particular tool. Not very useful right now, but we'll see how to use it when we design our part. Okay, the next tool is hide show. Suppose if you want to hide a particular element of your sketch, you can hide it using this particular tool. Suppose if I select this and select the circle that's there on my screen, now this tool will help you hide some of the elements. Okay, if you want, you can hide those elements. Now remember, those elements are only hidden, but they are actually present. Okay, they are only hidden, but they are in your sketch. Okay, so what you can do is to bring them back. There's no easy way. Actually, there is an easy way. If you see here, there is another tool. It is swap visible space. What it will do is it will hide the elements which are visible right now, and it will show the elements which are hidden. Okay, so it will swap the visible space. If you select this, you can see that now rectangle is hidden but circle is shown. Okay, so I can right click here and say hide show, or you can select the circle from here and click this particular tool and it will go to the visible space, and then I can go to swap visible space again and you can see that circle is back. That is how the swap visible space and hide show works. Now let us have a look at SketchUp basics. I will tell you about the conditions of a valid sketch. Now these conditions are important from the perspective, since if you don't follow these conditions, your sketch will become invalid. You won't be able to use a sketch for creating a part. So while making a sketch, keep note of these conditions and make sketch following these conditions. The first condition is that sketch should not be self-intersecting. Now how it works in CATIA I will show you in a moment. Let us first have a look at all the other conditions as well. The second condition is that sketch should not be open. Third condition is that sketch should be ISO constrained. You can also read it as that sketch should not have any degree of freedom. It should be fully constrained. The fourth condition is that there should be no standard points in sketch. The fourth condition is actually only particular to CATIA. In other CAD softwares there is no such condition. Now let us see how these conditions work out in CATIA. I'll first delete all the profiles that are there on the screen. Now to demonstrate to you the first condition, which is that sketch should not be self-intersecting, I'll create two circles. Now as long as the two circles are not intersecting, the sketch would be considered valid. Now suppose if I move this circle closer to the other circle and this circle now intersect the other circle on 2 points, right? So this sketch will become invalid since it is an intersecting sketch. One circle is intersecting with another circle, it will make the sketch as invalid. Let us have a look at another example. Suppose if I have a profile like this, okay, as you can see that this particular line is actually intersecting with this particular line. It will also make this sketch as invalid since the sketch is self-intersecting. Okay, let us have a look at third example. Suppose if I have a rectangle here and I have a circle here. Okay, Now this would also make the sketch as invalid, since you can see that the circle is intersecting with the rectangle on 2 points. So this would also make the sketch as invalid. Okay. If I move this circle away, it will make the sketch as valid, since the sketch is now no longer intersecting. Okay. The second condition is that sketch should not be open. Suppose if I have an arc here. Now since this arc is open, this will make this sketch as invalid. Okay. Of course I can close this arc if I want to. Say I create a line from here to here. Now this sketch will be valid since it is closed, okay, and it is also not self-intersecting. Okay, so it follows or it obeys two conditions. Okay, even if there is a small gap, say suppose if I create lines like this and there is only a tiny little gap over here, that will also make this sketch as invalid since there is an open gap. Okay. The third condition, which is also the most important condition, is that sketch should be iso-constrained. That is, it should be fully constrained. Okay. Now this is the most important condition because it would require most of the work and we'll need to practice a lot to make a sketch fully constrained. Let me just show you this by an example. If I create a rectangle here, now this rectangle, if I try to move it with my cursor, you can see that I can change its length as well as breadth. Okay, if I move it, I can change the rectangle's length and breadth, and I can also move it in space with respect to the vertical and horizontal. That means that neither its location and neither its dimension are fixed. That means it has many degrees of freedom which we need to arrest. Okay, so we can arrest these degrees of freedom using constraint. Okay, we'll study about constraint in the next video. For now, just see how I constrain the sketch. I'll use this constraint tool and apply some dimension value. Suppose this is a constraint. Basically I'll apply some value of say 350, and to this particular line I'll apply some other constraint, say let it be 140. Okay, now if I try to move my rectangle, you will see that I'm able to move this, but my length and breadth don't change. Okay, this is due to the simple reason that since I have applied these two constraints, okay, now these constraints arrest the length and breadth of this rectangle. Now to make it stationary so that it does not move, to make it fully constrained, I'll need to also specify its location with respect to the horizontal and vertical axis. I can do that using same tool. Let's specify this value as 70 and apply this value as okay. Now this sketch is fully constrained. How do I know that this sketch is fully constrained? Is because it has turned green. You can see the whole rectangle has turned green. This signifies that the sketch is fully constrained. Now this sketch follows all three conditions, which are that it is not self-intersecting, it is closed, okay, and also that it is fully constrained. Actually, it also follows the fourth condition, which is that it should have no standard point. There is no standard point in this sketch at the moment, so the sketch also obeys the fourth condition. If I want to create a standard point, you can create using this particular tool, point by clicking. If I click anywhere, it will create this particular point. Now the point that is shown here, it is a standard point. This is how a standard point looks. You have to keep in mind that such a point should not exist in a sketch. It will make the sketch as invalid. Now this point has some other uses. We'll see how we can use this point in other ways. For the time being, you can understand that such a point would make a sketch as invalid. Okay. Now let me show you some customizations that you can do to make the sketcher fulfill our needs better. We have already learned that we can display the grid using this particular tool in the Sketch Tools toolbar. Okay, as you can see that now the grid is displayed if I select this. Also, you can turn the snap on grid using this particular tool. Okay, you can also adjust the grid from tools, options, and from within the mechanical design branch. If you go to Sketcher, you will see the option grid under the Sketcher tab. You can turn the display grid on or off from here. Also, you can turn the snap to point on or off from here. Also, if you want to set the grid spacing, you can set from here. Suppose if I want a primary spacing of horizontal as 20 and the vertical spacing also as 20, and the graduation, that is the graduation between this 20 centimeter, I want it to be say just 2, and here also suppose if I want 2 graduations, and say OK. So this will set my grid size according to what I have specified. Okay, if you zoom in you can see, okay, this is my main grid and there are only 2 graduations. Okay, here also you can see there are 2 graduations and this is my grid. Okay, you can also allow distortions if you want. Okay, you can allow distortions. If you click this, you can specify horizontal and vertical spacing as different values, but if you don't allow this, you can specify here a value and the same value would be taken for the vertical. Okay, so this is how you set the grid size. Okay, now let us see how we can set the units. Suppose if you want to work in mm, you can set the units to mm. If you want to set the units to kilometer, you can set the units to kilometer. If you are a carpenter, you want to set the units to inches or foots, you can also do that. If you go to parameters and measure, units, and from here you can change the length unit, angle unit and time unit, and other quantities also you can change the units for these quantities. Okay, for length I want to change the unit to mm and say okay. So now if I try to make something, say apply some constraint value, you can see that the units that are displayed are in mm. Okay, so that is how units work. Before starting to create a sketch, you can modify the units according to your preference. Okay, now you can also set the plane size. By default the plane sizes may be small. You can go to tools, options, infrastructure, part infrastructure, and from the display tab you can modify the axis system display size that is shown. You can use this scroll to change the axis system display size. Okay, that is how you modify the plane size. Okay, now you can also modify your specification tree. If you want to hide it, you can hide using the F3 key on your keyboard. You can hide the specification tree using that particular key. If you want to display more things than what is displayed by default, you can do that using tools, options, and from the same tab, if you see here within the display, you have an option to select the things that you want to display within the specification tree, and you can set it from here. Okay, so those are some of the customizations that you can do in Sketcher to make things easier for yourself. So that's it for now. If you like the video, please give it a like, please share it and subscribe to the channel if you haven't done so already. Thank you for watching.